So that's why we keep a safety margin. We keep that safety margin somewhere around 8%. This area is the area of safety margin. So you have got your safe side. Below 8% of oxygen in the cargo tanks to avoid an explosion. There is a safety margin. Many companies, they go one step further. They say, okay, we have that safety margin, but we want to keep our operations and our crew, our personals more safer. So many companies, they go for this 5%. They say we'll go one step further and you have to keep this tin oxygen as 5%. Extra safety margin, we can call it. It depends from company to company, company dependent. But mostly companies, they are going for it. You can also call it, if you want, that this is the industry standard, 5%. They adopt it. Now what happens is, so we have established that 11, beyond 11%, it's the limiting oxygen concentration, our line of control. We have some safety margin up till 8%. Our company, some good companies, industry standard, other companies, they go one step more further, keeping the crew, industry, ship, cargo safe. They go up till 5%. So they have achieved this region below 5% in the cargo tank. Now let's say under the 5% area, there is at somewhere in this point F. I'll take some other color. Which one should I take? Magenta. Yes. I don't know whatsoever is the name of this color. Magenta, fuchsia, pink, baby pink, God knows. So somewhere underneath this 5%, where the hydrocarbon percentage is maintained at around, in this example, say 11%. It's just an example. It was maintained over here. Now, before doing tank entry, if you directly introduce air into the tank for gas freeing purpose, what will happen is, here is our this point we are already maintaining. You start to introduce oxygen in it, introduce air in it. So with the air, percentage of oxygen will increase, and what will decrease? The percentage of hydrocarbon. This curve starts to go down. This point starts to go down at this. Say at 15%, this point will be somewhere over here. At 10% of oxygen, initially which was like 4%, 3%, when this oxygen reaches to 10% inside the tank by the introduction of free air, the hydrocarbon percentage somewhere goes to like 7%. If we keep on increasing like this, we see at this particular point, it crosses the flammable mixture envelope for such a long time. And once the mixture is into that flammable mixture envelope, there is a risk of explosion. It can take place no matter. The moment it enters line over here, it can occur up till the time it is inside this thing. And we need to avoid that for safer operations, safer ships. Now, what the SCOT or the IMO recommends is, once you have maintained your point of this thing, mixture over here, do not introduce air directly into the tank, because then it is liable to go through the flammable mixture envelope. We have to keep our concentration below the flammable mixture. We have to keep this below the flammable mixture to keep our operation, our crew, our company, our cargo, our ships safe. At no point during the operation that this line should or the mixture of hydrocarbon should enter into the flammable mixture. So what the IMO says, you dilute this mixture with the introduction of inert gas. When you introduce inert gas, what happens is, of course, you are introducing now the third thing. Before there was hydrocarbon vapors and the air, now the third thing is coming, inert gas. Once you start introducing the third factor, what will happen? The amount of hydrocarbon is going to decrease, and also the amount of oxygen is going to decrease, which was original somewhere over here. It will come over here. It decreases. More introducing of inert gas, it decreases, and so does oxygen increases. So you bring this thing down, and then if you want, you can stop. Once you have brought it to this point H, how we'll determine H, we'll come to it later. Up to this concentration H, you have introduced inert gas. Bring it to up till this percentage of oxygen and this percentage of hydrocarbon, call it point H. And then once you have brought it to point H, then you can start diluting the tank atmosphere with the introduction of air, which will go somewhere like this. The oxygen is increasing, hydrocarbon is still less, and we have also the inert gas which goes like this, right? So it goes like this. Now point H, where do we need to keep the point H? How to find out this point H? There is a critical factor. We knew that this point H, when we introduce the air, the oxygen level will increase and it will be below the flammable mixture envelope. We need to find out what will be the point which will just touch or scrape through this flammable mixture envelope over here, which will just go tangent or a little bit below the flammable mixture envelope. Once we determine this thing, we know that this is the minimum point. This is the critical point above which we do not have to start introducing the air. We have to introduce the air only after crossing that point, only below, explicitly below, appreciatively below that point. We need to find it out. So that's why they have named it critical dilution with air line. For every product, there will be this one particular concentration of hydrocarbon at which if you start introduction of air, this line will go somewhere like this, and it is going to be just below the flammable mixture envelope. This will be kind of your boundary line. This will be like your minimum value, that prior to introducing the air, you have to go well below this minimum value. The value, which will be the critical dilution with air. You have to go below this. This is the importance of this. Once you know this, you have to go well below this particular level, and then only you can start introducing air. And your graph or your line will never go inside the flammable mixture envelope, and you will be safe. What else? So this is how this flammable mixture is done. Flammable diagram is done. So basically, we know that flammable diagram gives us the flammability relationship between hydrocarbon gas, the oxygen, and the inert gas, which comprises of nitrogen and carbon dioxide. We are getting it from IG plant. Some vessels also have their own nitrogen generator, which generates nitrogen from the air. And we know that flammability depends upon the proportion of all these three gases, that is hydrocarbon, oxygen, and the inert gases, which forms the core safety model behind this inert gas system and tank cleaning and gas ring. Because during tank cleaning you have to keep the atmosphere safe, you cannot directly start introducing oxygen. We have already seen it why. So we need to dilute with inert gas, and then we need to start inserting the air concentration will be within the limit, and you have not touched the flammable mixture as well. Also, when you're doing cargo ops, you have to keep it inerted. Why? Because hydrocarbon vapors will be emitting over there, oxygen will be there, and with the inflow of oil, static discharge might be there, and if the spark occurs, possibility of fire. So that's why. And what else? So the inert gas, after the as the inert gas is introduced in it, we know that it reduces the oxygen level, and it also reduces the hydrocarbon level in the mixture, and the mixture stays out of the flammable envelope. That's the main idea about it. Jai Mata Ji ki. Thank you very much.